Welcome to another module of the Pic16F877. This is SPI mode. And what is the SPI? SPI is high-speed serial communication port. So this is another serial communication, but they have high speed, and they have their own clock and the data, and they have the advantage that they can have the full tablets. That means can send and receive at the same time. But the distance for transmission is very short, but the speed is very high, in megabit per second. And for the communications, there are four lines. Because the SPI mode, we can use the multi-master and multi-slave. So we have a special line. We call this one. This is the chip select. So that means if we want to choose which slave, we will that this line will come to zero. Okay, this is active 0 here, and another line is the clock for the data. And this one is the data input, and this is the data output. If we want to communicate with between two bits, so input of one bit is the output of another bit. Okay, so in to out and out to in. Okay. So this is the example of the connection between one master and multi-slave. So that means we have many lines connect to the slave, right? So if we want to transmit the data for slave example, slave 2. So we take this line will become to 0 and another will become 1. Okay. And in our pic, the line is at the pin number 22, 24, 23, 18, and pin 7. Okay, pin 7. Okay, pin 7. This is the port A, and another the remaining are port C. Okay. Okay. So this one is the principle of working of the SPI communications. The first is, of course, we have to active the chip select line, okay, to set this one equal to 0, and then the data will load to the buffer here. And in the SPI mode, we have two modes. One is half doublet and full doublet. What is a half doublet? That means we just one bit just transmit or receive. Okay, just transmit or receive. But the full doublet, that means two bits can transmit and receive at the same time. So the speed is very high. Okay. And one more important here is like this slide. Okay. Here is example. This one want to transmit the data here, right? So this one will push the MSB, the most significant bit, to the low significant bit here, right? And then another again to here, right? So the shift bit is the most significant bit first, and then the other. Okay, then two low significant bit. Okay, and if we set the full doublet, so if we set the full doublet mode, so that means when this one transmit into the LSB here, this bit will also transmit into the LSB here. Okay, so this is the full. And there are some slide. There are some register associated with the SPI mode. Here you can see that the special function register here use the same as the RS-232 communications. So also we use 2 to generate the interrupt, right? And this one is to transmit or receive the data here, and this one is for control the communications, and this one is for the check the status of the data. Okay. And let's have a look how the data is transmitted. First, we set the configuration for the transmission by setting these 2 bits. Okay, these 2 bits. No matter what you choose, right? So if we choose this one equal to 0 and this one also to 0, so the timing will be like this. Okay, and the data is here. So when we look at this, right? So just have a different dash. The bit will be transmit when this one is active, and if we choose this mode, right? The transmit will be transmit when it's low. Okay, so that's the point here. Okay, and to transmit the data is very easy. When you already configure the SPI mode, just give them this. Just give the buffer the data we want here. Okay, here, so this one we just give to the SS pop register, and then it will transmit the data for you. And after the transmit finish, the interrupt will be generated. So we can check the interrupt to know that the transmit is complete. Okay. This is the bit configuration for the SPI mode. Here we can choose for the SPI bit. Example, we choose this one is 000, so that means it is the max bit. The max bit is FOSC divided by 4, so the megahertz. Example, we use 20 megahertz here, so this is transmit 5 megahertz, 5 megabit per second. Okay, it's very fast. And as I said that we can configure the CKP. This is active receive or low receive. Yeah. And for the register for control the communication, because we use the SPI mode, so we just concentrate on Pic16 here, right? So this is receive overflow indicator. That means a nearby is received. That means we transmit the data, the new data to this one, but this register still have the data, so it will have error. So remember that before we want to transmit the new data to the SS buffer register, we must clear this one first. That's first. Okay. And the bit number 5 is for enable the SPI mode. Okay. And this one is the data status check bit. Okay, this one is in our SPI mode. Okay, so when it's compiled with the SKA here and CKB here. If it is 1, the input data is same at the end of data output, and it is 0, input data same at the middle data output. Okay, so just leave as default. Okay, and this is the CKE we compile with the for CKB here. Okay, and bit 0 here is very important. We check this bit for the buffer full status. When we receive complete, when the receive complete, the asset buffer is full, so that will become 1. Okay, become 1. And this one is the example for the config the SPI mode here, right? As I said, the SSP state start, we just leave its default, and here we enable the SSP by this SS pen here, right? And we combine with the CKP here, right? Okay, and this one is for the speed, we leave it as FOSC divided by 4, so the maximum bit speed is OSC divided by 4. Okay, this is the code summary for the configuration of the SPI mode. Okay, so after we config for the master or slave, we just for the master example here, we can transmit the data by give the data to the SS pop register. And for the slave, it's very simple. Here you see the flowchart for the slave, and when the chip select is choose, right? So that means it will go low, right? And based on the CKP, and the CKE here, the data SDI will go inside the SS pop here, SS buffer register. Okay, and then if when it transmit already 8 bit here, the bit 0 is here, the interrupt flag will turn on here. Okay, so that means if we want to read the data, we can use the interrupt here, and we check the this bit, and then we perform the read the buffer here, the SPI read here. Okay, and after we read the buffer, we set the SSBF equal to 0 for generate another transmission or generate another interrupt for reading. And this is similar to the previous slide, just different. It is CKE equal to 1, but we don't care about CKE equal to 1 or 0. We just care about when the interrupt happen, right? Okay. And there are some advantages. You can read on the slide. Okay. Some advantages, and also they have some disadvantages. Okay. Also some disadvantages. And if we don't want to use the register, we use the compiler CCSC. It's very simple. We just concentrate on some function. First is set up SPI. Here we can set is either master or slave. Okay, and the clock CKB or CKE high to low or low to high, and then we can set the speed for the transmission. Okay, this is the smart speed. Okay, example, this is the example of the transmission for the configuration. And for the transmission, it is also very simple. Just use the SPI write data, and this is for the master. And for the slave, is also the same configurations, but for reading the data, we just use the SPI read here. Okay, and here we check the SPI data is ready or not. Okay. And let's have a look at example. Here we configure the transmission for our transmission line here. Okay, for our transmission line here. So on the transmission line, we give some register and pull up register to the VDD. Okay, this is 5 volt, and when we click this button, it will transmit the data example number 5 to the big slave here, and then it will display on the terminal. And this one is the code for the example. If we use the CCSC compiler, it's very easy. Just set up here, right, and then just use SPI right here. That's all. And for the slave, right, for the slave, you also set up the SPI, also set up the interrupt, right, and we use the interrupt for receive the data. If the data is equal to 1, that means the PF, the buffer is full, okay, equal to 1. So we read the data, because we use the CCS compiler. So after this interrupt, all the compiler will do the remaining for you. Example says the interrupt flag equal to 0, PF equal to 0, or yeah. And another more complicated case here. Example, in the question number 1, we just transmit the data from master to slave. If we click the button 7 here, it will transmit the number 12. And if we click the button here, the slave will transmit to the master again the number 15 here, okay. And question number B is the example of the full duplex. That means when you click the button on the master here, they will transmit the number 12, and at the same time you will receive the number 20. You will receive, right? We don't need to click button. So this is called the full duplex. Transmit and receive at the same time. And this is the example code on the master. Okay, on the master you just config for the master here based on the table. Okay, go to the previous slide to config it, and then we perform the transmission and receive. So if we click the button 7 here, right, we want to transmit to the slave number 12 here, we just SPI write here, okay. And this one is very easy, just write the data to the buffer here, and then we perform the reading, So this one is to receive the buffer, to receive the data to the buffer, okay. And then we check the bit buffer, the buffer is full or not, and then we just read the data. Just read the data here, right? Just read the data. And this is the code in the slave. The code in the slave is also very simple. Just config for the slave here, right? SPI init here, and then wait here. And when they have the interrupt, right? If we click the button, we will transmit we will give the number 15 to the buffer, to the SS buffer, right? And then we read first, okay. We read the number from the master, and then we give the 15 to the SPI write to transmit to the master again, okay. And this is the code we write in the CCSC compiler, okay. So similar, we just click the button 7 to transmit the data to the slave, okay, to the slave. And in the slave, if we want to transmit the data, we just click the button 7, pin 7 again, and then we give the data to the SS block, and then the data will be transmitted to the master. Okay. So let's have a look at animation. First is this pic is 10 and 50, right? When we click the button 7, we see 50 and 10 again. Okay, 50 and 10. So we can transmit and receive at the same time. Okay. And if you want to know more about the details, so please have a look at the code again. Okay.